In this problem, we're given at age x surviving 2 years and dying the next year is 0.1 for t between 0 and 9. We want to calculate the probability of surviving 2 years starting at age x plus 5. So the first thing we're going to do is look at this equation, or rather we're going to rewrite this. So that's the same thing as dying at age x plus t over how many people there are at age x. So this is just a formula. Now this is going to equal 0.1. So the number of deaths at age x plus t is going to be 10% of the population. Okay. And this holds for t equals 0, 1, all the way up to 9. So this means 10% of the population dies for any value between 0 and 9. So we can rewrite our population formula as 10 minus the time. Let's think about it. Let's say hypothetically we start with 10 people. That's why I have 10 here. At time 1, 1/10 of the population dies. So that means 9 people are left. At time 2, 10% of the people are dead. So that means there's 8 people left. So every time you're subtracting by 1. It's 1/10. Okay. So I want to find probability of surviving 2 years at age x plus 5. So that's the same thing as how many people in the population x plus 7 divided by how many are at age x plus 5. And all we have to do is just plug in, t equals 7, t equals 5 into this formula. So we get 10 minus 7 over 10 minus 5, which is 3/5. And writing it as a decimal, it's 0.6. Okay. So there's about a 60% chance that you'll survive 2 years. Okay, next problem. The probability that a person age 20 will survive 30 years is 0.7. So I'm going to rewrite that like this. 30p20, 0.7. Probability that a person age 45 will die within 5 years. So that'd be 5q45. And then another person age 40 will survive 5 years. So we can write that as 5p40 is 0.0475. Probability that a person age 20 will survive 20 years. That's 20p20. Then another person age 40 will die within 5 years. So it's 5q40 is 0.04. We want to calculate the probability that a person age 20 will survive 25 years. Okay. So that's what we need to find. So what we're going to start with is we're going to let L of 20, so the population times 20, to be 1. Starting with the first bullet point, we have L50 over L20 is equal to 0.7. And since L of 20 is 1, that implies that there are 0.7 people left at time 50. Okay, now let's work with the second and third bullet point. So let's start with the second one. We have 5q45 times 5p40. I'm just going to write it using the formula. So this will be L45 minus L50. And this is L45 times L40, which is equal to 0.0475. I can cancel out the L45s, and I'm left with L45 minus L50 over L40 is 0.0475. And then looking at the third bullet, we have 20p20, which is L40 over L20, times L40 minus L45 over L40 is 0.04. The 40s are going to cancel. I'm left with L40 minus L45 over L20 is 0.04. I let L of 20 be 1, so I'm going to replace this with 1. So we get L40 minus L45 is 0.04. So the other thing is that L50 is 0.7. So I can replace that. And yeah, we'll just have it like this. Okay. So now we're left with these two equations. And there's two unknowns, so technically we could solve for L40 and L45. But let's keep in mind we want to solve for 25p20, which is L45 over L20. We know that L of 20 is 1, so really we're just looking at how many people are left at time 45. So we want to solve for L45. So there's, let's see. Okay, this one I'm going to multiply both sides by L40. And then I'm going to bring the L45 over. So that'll be 0.0475. L40 minus L45 equals negative 0.07. I'm going to write that underneath this other equation. So we have a system of linear equations. We have two unknowns. And so here you can use elimination, you can use substitution. Either way, you'll end up getting that L45 will be 0.736903. Okay, moving on to the next problem. So this one is interesting because we're given that at age 60, we're probably surviving to age x minus 60 and then dying the next year. So here x, we're given 60 up to 63. So the first one you can think of it as just Q60, and then surviving 1 year, dying the next, surviving 2 years, dying the next, surviving 3 years, dying the next. Okay, so let's see. A good place to start is with 0.07. So we know that surviving 2 years and dying the next year is 0.07. So that's the same thing as the number of people dying at age 62 over how many people there are at age 60. So at age 60, there's 1,000 people. So that's D62 over 1,000. So that means at age 62, there were 70 deaths. Now we can solve for how many people there were age 62. So we can just add 780 with 70. Because think about it, like we're working backwards. 70 people died and you were left with 780. So now there has to be 850 people before. At time 61, 100 people died, and then you had 850 people left over at time 62. So we're just going to add that and get 950. Okay. So I want to find how many people died at age 60. Well, if at 60 I had 1,000 people, 61 I had 950, so that's a difference of 50. So how many people died at age 60, or what's the probability of dying at age 60? That's the number of people dying over the total population, which is 0.05. So again, this is D60 over L60. Okay. Next problem, we're given 2,500 light bulbs, and we're seeing how many are left over for each time. Okay, and we want to see how many light bulbs will be needed at the end of 3 years. And whenever a light bulb is burned out, it will be replaced at the end of the year. Okay, so from this table, we can find the probability that the light bulb will make it to the next time. So at time 0, you're given 1 million light bulbs, and only 800,000 survive. So that's just 0.8 of them. Now at time 1, there's 800,000 left, and then at time 2, there's 600,000. So that's just 75% left over. So I'm just basically, for each one of these, I'm just dividing like this. Okay, so I'm just saying, okay, what's the probability of making it to the next time? Now, time 2, there's 600,000, and there's 300,000 left. That's exactly half. Okay, then time 3 goes from 300,000 to 0, so the probability of surviving is 0. Okay, so we're going to start off with 2,500 light bulbs. So this is time 0. At time 1, we know that 80% of the light bulbs will survive. So 80% of 2,500 is 2,000. Now, from 2,000, we go on to the next year. Well, the probability that the light bulb will survive is 75%. So we do 2,000 times 75, and that's where we get 1,500. Okay, and time 3, well, to go from time 2 to time 3, we look at P2, and we know that half of the light bulbs survive. Okay. But we're not done. We want to see how many, we want to take into account the light bulbs being replaced. So at time 1, there's 2,000 light bulbs. That means 500 of them burnt out. So we have to replace 500. Now this 500 is new. It's going to take the probability as 0. So the probability it survives is 80%, which is 400. And then the probability to survive the next year is 0.75. So that would just be 300. So far, time 0 is 2,500. Time 1, you have 2,500. Time 2, there's 1,900. So you need to add another 600 in order to make 2,500 light bulbs. Because at every time, because you're going to be replacing the light bulbs, at every time you better have 2,500 light bulbs. So 600 is going to take the probability of 0.8 because it's brand new. So that's 480. If I add this up, at the end of time 3, this is 1,530. Now, how many of those light bulbs will be replaced? Well, we know that there has to be 2,500 light bulbs. I'm left with 1,530 at the end of 3 years. So that's 970 light bulbs that will need to be replaced. Okay, last question. Oops. So we want to find the variance of x, where x is a number of survivors to age 83 from a cohort of 5,000 lives at age 80. So I'm basically looking at 3p80, which is L83 over L80. And that's 4,790 divided by 5,000, which is, let's see, that's 0.958. Now we're looking at the variance. So the variance, this one we're going to be using the binomial variance. So that's NPQ. So we start with 5,000 lives, that's N. Probability, P is the probability of survival. In this context, surviving 3 years from age 80, which is 0.958. And then the probability of death is Q, which is 1 minus 0.958. And the total the variance is 201.18.